Hey dudes, welcome to my channel, Salama 2020. Today's presentation on how to illustrate polynomial functions. And our lesson objectives here to illustrate polynomial functions, to identify polynomial functions, and to determine the degree, the leading term, coefficient, and the constant term, and to write polynomial functions in standard form. Okay, so let's define first what is polynomial functions. A polynomial functions is in the form of f of x is equal to a sub n multiplied by x raised to n plus a sub n minus 1 multiplied by x raised to n minus 1 plus a sub n minus 2 multiplied by x raised to n minus 2, and so on up to a sub 0. As we have also seen here, only one variable, that is x. We can say that f of x equivalently to a functions in x. And we notice that x is raised to unique power. So what do you mean by unique power? So it says that no each term has the same exponent. So, hindi dapat magkapareho ang ating exponent sa bawat term. And also, where n is a non-negative integers. So, the non-negative integer, it refers to the power of x or the exponent of x that must be positive integers or 0. Okay, so our n is our exponent, and it should be written in a decreasing order of power of x. We have also other components for the polynomial functions. So these are the coefficients in each term. So in our first term, we have the coefficient of e sub n. In the second term, e sub n minus 1. And so on. So a coefficient is a number that multiplied by x, or a number placed before x. So the coefficients, it says the numbers that appear in each term. So we have also the last term of this particular functions of x, that is called the constant term. It refers to the number without a variable. And our first term is a sub n x raised to n is our leading term, and the a sub n makes our leading coefficient. If you want to find the degree of the f of x or the functions of x, so we can determine the highest power of x or the exponent of x. Okay, that would be determined in our leading term. The exponent here is n, and it is the highest power of x. We have chosen here decreasing powers of x and writing a term on descending order of power of x. That is called standard form. For example, our given functions, or the f of x is equal to negative 4 multiplied by x cubed plus 8 multiplied by x raised to 4 plus 2x plus x squared plus 22. In order to be a standard form, we must look first into the exponent of our given f of x and write to decreasing order yung pababa ng ating exponent ng bawat term. Okay, ito na yung ating standard form of f of x. So our leading term is 8x raised to 4. Our second term is negative 4x cubed, and the third one is plus x squared. Then we have the exponent of x here is 1. So to complete the descending order power of x, so that is a 2x. Then the last term that is called the constant term, that is 22. So our f of x in its standard form is 8x raised to 4 minus 4x cubed plus 8x squared plus 2x plus 22. So this time we have the descending order of power of x. Other than f of x, polynomial functions can be written in different ways, like p of x. P of x is equal to the sum of all terms, and the other is y is also equal to the sum of all terms. We're using here the y as a function of x, so we know dy is equal to f of x. It shows different notations but the same value or the same functions of x. Okay, so let's elaborate more in our example. So we are using here the y as a function of x. So 3x squared plus 6 cubed plus 2x. In order to be in standard form, so we must rewrite our polynomial functions into descending power of x. So we have here the leading term, that is 6x cubed. Then copy our second term, 3x squared, then plus 2x. Okay, so let us determine other components of polynomial functions. To give the degree of the functions, the type of functions, leading term, leading coefficients, and the constant term. Let us determine first the degree of these functions. Okay, so the degree it defines as the highest exponent of the power of x. So the highest exponent is 3. Okay, that is our degree of the functions. Okay, so we have the type of function. This is cubic, and we also have the leading term. So our leading term, that is first term with the highest exponents, that is 6x cubed, and the leading coefficient, that is 6, and the constant term. So we know the constant term is the number without a variable. So our constant term here is 0. There are types of polynomial functions based on the degree of the polynomial. The most common types, so we have here the p of x is equal to a x raised to 0. So the exponents here is 0. So this is known as the zero polynomial functions, or what we call this as 0 degree or degree 0. Then we have another function is equal to ax raised to 1 plus b, or equivalently to ax plus b. So this is called the linear polynomial functions. Because of the exponent of 1, the highest power of x is 1, and this is a first degree or the degree 1. The other functions, p of x is equal to ax squared plus bx plus c. The highest exponent here is 2. So this is a quadratic polynomial functions, or the second degree or degree 2. And we have ax cubed plus bx squared plus 6 plus d. The highest exponent is 3. So this is known as the cubic polynomial functions, or the third degree functions, or degree 3. And we have also here the p of x is equal to x raised to 4 plus bx cubed plus 6 squared plus dx plus e. So this is known as quartic polynomial function because the highest exponent is 4, and this is called the fourth degree of a functions, or degree 4. How do you know if it's not a polynomial function? So let's find out. Okay, number 1, f of x is equal to x squared plus square root of 4x minus x. Okay, by inspecting its term, so it is not polynomial function since it has a square root of variable x. So look at the second term, we have the square root of 4x For number 2, f of x is equal to x raised to 2 thirds plus 3x plus 1. And also, this is not polynomial functions because it's fractional power on the variable x. Look at the first term, x is raised to 2 thirds. Okay, for number 3, f of x, yan, to x cubed plus 3x x minus 2 plus x plus 4. So, it's also not polynomial function because we have the negative power on the variable x. Okay, for number 4, yan, we have 6 over x squared, not a polynomial function because of the variable x is in the denominator. These are all the sample not considered as polynomial functions. Okay, so let's try to answer this one to determine whether a polynomial functions or not. Okay, number 1, f of x is equal to 5. It is a polynomial functions or the zero polynomial functions. Since 5 can be written into 5x raised to 0. Any value of our base basta raised to 0 is equal to 1. So 5 times 1 is 5. So the exponent here is 0, or this is called a 0th degree. For number 2, f of x is equal to x raised to 2 plus square root of 3x plus 2. So our middle term, it contains the square root of variable x. So therefore, this is not polynomial functions. Okay, since the middle term, it contains the square root of the variable x. For number 3, so our given f of x is not polynomial because it contains our first term with a fractional exponent, that is x raised to 4 over 5. Okay, for number 4, f of x is equal to negative 3x. So this is linear polynomial functions because the variable x it's raised to 1. So this is a first degree functions. So our topic today gives a knowledge of basic concept of polynomial functions. Our next topic will be writing a polynomial functions in factored form. So thanks for watching. God bless us all.